Chapter 15, the second part, 2 of 3, is going to deal with a couple alternative ways to get water. First one is a very reliable resource for the most part, if not overused, and that's groundwater. We can supply cities, we can supply them with water for food to drink, as long as the aquifers in those regions are not overpumped and they can replenish faster than there are deep. Groundwater, of course, in some areas is being withdrawn faster than it's being replenished. Most aquifers are renewable. Most of the water in the United States does come from groundwater. There are some regions, of course, like in the Great Lakes, where the cities near the shorelines get their water from the Great Lakes, but otherwise most of it is from the ground. Very reliable resource, again, but we can't overdo it. Some areas have water tables that are falling, and of course, part of that goes with it is because we have too much agriculture in that area, particularly for the advantages of withdrawing groundwater. Useful for drinking and irrigation pretty much everywhere. It's renewable if not overpumped or contaminated with pollutants. Cheaper to extract than most surface waters. The disadvantages is they can be depleted. They can cause something called subsidence. Think about it this way, when you pump water out of the ground, that's volume, it takes up space. So what happens is sometimes when we lack that space, we get collapsing, and we'll show you a picture of Mexico City in a bit where this has happened. Some deeper wells are non-renewable. We've got things called fossil wells, which are miles deep, and we know there's water down there, but should we really tap into that? Not really necessarily deemed renewable because they replenish so fast. So slow. Pollution of aquifers lasts decades or even centuries. In the region we're in, water moves at about a foot a day after being replenished. And what happens is if there's a pollutant in there, it's going to stay in there. It doesn't come out very easily, although overall ground is it's not perfect. Here's a little case study. In the central part of the United States, underneath this area right here, we have the largest aquifer. It's called the Ogallala Aquifer. In the states all the way from South Dakota, Nebraska, Colorado, Kansas, New Mexico, Texas, and Oklahoma draw from it. Well, Texas has a huge population. Texas has great weather for growing food year-round. The rest of those regions don't. The prairie states are seeing a reduced amount of water in that aquifer. Most of it's going in this region to Texas. Is that really fair? Now, that's within countries are actually seeing things like that too. So we know the Ogallala Aquifer irrigates the Great Plains, very slow recharge. Water table is dropping very fast. It's being pumped out about 10 to 40 times faster than the recharge. Government subsidies are continuing to help farming, but that's depleting the aquifer even further. So we're encouraging that farming, but encouraging farming also is encouraging the irrigation, which is depleting it. Biodiversity, of course, is threatened in some regions because they just are. What happens when aquifers are depleted? Well, it does limit future food production. You can't grow food without water, and if we don't have groundwater there, if there's not enough surface water, we're not going to grow anything. Of course, there's a bigger gap between the rich and the poor. We get land subsidence. Mexico City, I'll show you a picture of it in a second, in the San Joaquin Valley in California also. Groundwater, of course, overdrafts near coastal regions. This is very interesting because if you think about Florida, now Florida being like this, excuse my bad drawing, what happens is we've got lots of people that live in Florida. What happens is they have all these wells set up and they're drawing groundwater. If you can imagine the groundwater being here, being pulled up, what happens is the coastal regions, so the ocean, what's happening is we're getting water drawn in. That's called salt intrusion. So what happens is that groundwater gets contaminated with salt water, and therefore it's Mexico City. Look at it. Look at the substance that's occurring. That was not always the case. You can see what's deemed rolling hills. That's because the land is sinking because we are withdrawing. This is a picture of the San Joaquin Valley in California. Believe it or not, that land was all the way up here in 1925, 1955. And that was in 1977. You can see that guy down there. The land is sinking because, again, so groundwater depletion, we need to use it more efficiently. You can see a picture of drip irrigation over there, which we'll talk about later. We need to subsidize water conservation. We need to limit the number of wells. We need to stop growing water-intensive / thirsty crops in dry areas. Maybe we raise the price of water. Maybe we give people some money back if they conserve water. Maybe we build rain gardens. Maybe we use permeable paving material. So what happens is when it rains out, instead of that asphalt or concrete pushing everything away, maybe it actually absorbs it and goes back into it. So the idea of these deep aquifers, again, miles deep, maybe they contain enough water to provide for billions of people. The major concerns are they're not renewable. So if we tap into them, who knows how long they'll last? Maybe they'll last a long time. Little is known about the geological. We don't know about the ecological impacts of pumping. Maybe they have bacteria down there we don't even know about. Some flow beneath more than one country. This is thought about in the Middle Eastern part of the world. What if Saudi Arabia starts pumping this out and then that affects another country around it? And of course, we don't know the cost of tapping. Okay, another idea is, of course, putting dams up. Think about the Hoover Dam, which is the big one on the Colorado River just south of Las Vegas, and reservoir systems. These are great, positive, but they also have some very negative. The main goal of a dam and reservoir system in general is to capture and store runoff. So all that water can be used in other ways. It can actually help control floods. It can generate electricity. It can supply irrigation water and recreation. The Three Gorges Dam in China did a great job of doing this. Of course, the other thing is it did displace people. So this is a picture of a dam and all the possible good things and bad things about it. First of all, it can provide irrigation. So what happens is we have this large reservoir behind the dam, and people can pump that out and reroute it for agriculture. That's happening along the Colorado River. Provides for drinking water, obviously. It's useful for recreation. You can see these people skiing or tubing or whatever they're doing there. Very happy. Can get cheap electricity from it. Dams are very expensive initially to build, but then afterwards they're very cheap to run. And it can reduce flooding downfield, and that was a big selling point for the Three Gorges Dam in China because it was very prone, the Yangtze River in that case, to flooding. The negative side, flooding land does destroy forests or displace people. So what happened is a lot of those people along the Yangtze River actually had to be moved into cities. They were used to rural life and of course in farming, and they had to be moved to cities. Large losses of water through evaporation. If you think about it, we've increased the surface area greatly here, thus evaporation is going to be higher. It does deprive downstream croplands of things like silt. So silt does build up in here. Not only does it not go down there where it's needed to replenish, but it oftentimes has to be dredged out. The dam could fail, could flood everything below it, and it does, of course, disrupt the migration and spawning of some fish per system. So it does increase reliable runoff. Remember, reliable runoff is that which we can count on every year. It reduces flooding, and we can grow crops in arid regions. Of course, we displace people. Regions can become flooded behind it. Impaired ecological services of the river. Loss of plant and animal species. It does fill up with sediment, which needs to be dredged often. And it can cause other streams and lakes to die. Here's kind of a little look at how these dams work. Again, pretty cheap running once they're going, very expensive initially, but once they're going, it's an excellent source of energy. So what happens is water gets through this intake right here. They go through the turbine, and that turbine will rotate and produce with a magnet coil, of course, electricity, and then it's off. So it's very cheap, and then it goes back down here. The problem is, of course, we can get all that sediment going here, and if it goes high enough, of course, it's going to block our intake. So how can dams kill an estuary? Remember, in estuaries where fresh and salt water meet. Think about the Colorado River, which we talked about before. Water reaches the Gulf of California, but very little. We don't have nearly the freshwater flowing system that we once had. It does threaten the aquatic species and riverine species that live in that area. The current rate of river withdrawal is much less and not really sustainable anymore. Much of the water that's used for agriculture, so diverted ahead of time, it's inefficient with water use. We really shouldn't be putting that much water into thirsty. Reservoirs, of course, the areas behind the dam do leak water in the ground below. That can be a good thing. It can recharge groundwater. but much of the water is lost through evaporation. It does fill up with silt. It could eventually lose the ability to store water and create electricity. The reality is we need to conserve water, we need to control population and really slow development down. You can see a picture, this is actually a guy walking where a majority of the Colorado River used to be. This is in the Baja Peninsula of California and Mexico. And what happened is where the river was one time it dried up at this point. Another idea is, of course, we can transfer water from one place to another. One little case study of this, unfortunately, proved to be devastating, is actually Aral Sea, which we'll get to in a bit. China, of course, moving it from the north to the south water diversion project. They've diverted 6 trillion gallons of water. Is that a good idea? A great example closer to home is the California Central Valley. They've actually set up a series of aqueducts, which I'll show you in a second. And of course, we worry about the eco behind these. So in California, of course, we've got the mountainous regions right in here. Northern California gets much more rainfall than Southern California. Southern California, of course, has many more people. So what's happening, and it's got better weather, quite honestly, to grow more food, is they've had to reroute water here. They've built a series of aqueducts all the way down to Southern California in order to sustain their people population and to grow their crops. They've actually had to set up 8 steps in order to get water there, and this is just one example of it. And you can see what happens is they will then divert the water to the side to grow those crops. So, not smart either. Another example, of course, is the Aral Sea disaster that I mentioned, very large-scale transfers in dry Asia. What happened is, this is in the Russian area. They've seen great wetland destruction because they've taken water out of this very large sea. They've seen desertification. It's greatly increased salinity. If you think about it, the amount of minerals that are in any water, no matter if it's deemed salty water or not, there's some minerals in there. So what happens if you take the water out, you're going to increase the salt concentration. Because of that, we've seen great fish extinctions, and of course we've seen great plant extinctions too, because what's happening is nothing can live in that real. We're getting wind-blown salt going to other areas. It's depositing as far east as the Himalayas and melting their snow prematurely. It's altering local climate because of this, hot and dry summers, cold winters. They've tried to restore it. The cooperating neighboring countries have tried to restore this, but it hasn't been very efficient at all. They need much more efficient irrigation system. And of course, they have a dike construction to raise the lake level. This real quick. In 1976, this was the Aral Sea right here. Take a look in 2012. It's been reduced to this area right here. And you can see all that white stuff in there. That's basically salts. That's the salts that were in there, and they've dissolved out. And of course, nothing can grow there. So because we've transferred water out to try to grow crops in all these different areas and all these different countries that are involved, it's really dried it up. All right, that's it for part 2.